Think math.
A half plus a quarter plus an eighth, carried on forever, comes to 1. But hold on, what does adding forever actually mean? Addition is an operation on 2 numbers at a time. 3 numbers take 2 additions, 10 numbers take 9. Infinitely many never finish, however long you work. So how do we decide the answer to a calculation that never ends? Mathematics answers like this. We never add infinitely often. Instead, we lay out the finite sums. The sum of the first term, the sum of the first 2, the sum of the first 3. That list is called the partial sums. The partial sums are themselves a sequence, and the value that sequence closes in on is what we define the infinite sum to be. Check it on our example. 1 term gives a half, 2 give 3 quarters, 3 give 7 eighths, 4 give 15 sixteenths. These partial sums creep closer and closer to 1. No partial sum is ever exactly 1. There is always a little missing. And yet the place they head for is unmistakably 1. That is why we call the value of this series 1. Now the words are clear. Adding forever does not mean performing infinitely many additions. It names the destination the partial sums are heading for. Think back to the square we shaded by halves. The shaded area was the partial sum, and the whole square was the destination. So a series is not a new operation. It is the limit of a sequence, nothing more. This definition buys something else. It lets us speak precisely about the cases that head nowhere. Take 1 minus 1 plus 1 minus 1, carried on forever. The partial sums swing between 1 and 0. There is no destination, so this series has no value. We say it diverges. Rather than argue about the answer, we look at the partial sums and settle it. To sum up, adding forever means building the sequence of partial sums and taking its limit. If the partial sums close in on a value, that value is the sum of the series. If they do not, there is no value. The word infinite has been turned into a list of finite calculations. That one shift unlocks everything we will do with series from here. A sip of math every day, here at Think Math.